Just wanted to say a few words, guys, about solving linear equations in the intro. There's 20 questions on this first row. Solving simple linear equations, here they are. Here's a couple of simple little examples here of the sort of equations that we'll meet, especially at the beginning, very straightforward ones. So we want to know the rules that we can adopt and feel fairly comfortable and safe. So I thought it's with what we do. So I thought I'd say just a few words just to get you into the subject, make you feel comfortable with it. Basically, we always think of equations, no matter how difficult they are, even more complex equations, as having scales. And this gives us our rule in our mind's eye. Because basically, with a set of scales that are balanced and equal, what you do to this side, you must also do to that side in order for the scales to remain equal and balanced. So you could add something to here, provided you add the same amount here, the scales will stay the same. So the same amount both sides is the key thing to remember, and it's the whole of the side. So we could add to this side and add to that side the same amount. So I've illustrated it there with a coin or ball. Put one ball on here, one ball on here of the same weight, then the scales will remain equal. So we can add so much to the sides, provided it's the same. We can also subtract, so we could take off something here, provided we took off the same amount here, then the scales would remain the same. So we can add and subtract, that's fine. We can now also, we can double. Double this side will equal double that side, so the scales will balance. Triple will equal triple, and quadruple will equal quadruple. So we can effectively times 2 lots of this, 2 lots of that, 3 lots of this, 3 lots of that, and the scales will remain the same. So that's another thing we can do then. And similarly, we can also divide, because a half of this weight would be the half equal a half of that weight, and the scales would remain the same. Similarly, a third of this weight would equal a third of that weight. So that leads on to the notion of dividing, doesn't it? We can divide by the same amount both sides of an equation. So there's basically the things we can do. So basically, if we look at this example here, we'll see how we do it in practice. So the plus 3, I want to find out what x is. So if I take 3 from both sides here and here, say, in my mind's eye, this will disappear, because you get 0 and you'll be left with what you wanted, x, in the problem. 4 take 3 is 1, so you can see that this tells you that x equals 1. Right? So that's what we're doing, and that was subtracting 3 from both sides. Minus 3 from this side would enable that 3 to cancel, and minus 3 from this side would enable the 4 take 3 to equal, for there to be 1 left, so x would be 1. But that's not, we don't usually write down that long-winded process. All we do is the shorthand way to do that is to move it across equals flips the sign. So can you see in practice then what happens? Effectively, we can move this 3 across the equals as long as we flip the sign. So that can move to minus 3, and it can be removed from that side. So you write a fresh line, of course, and you get x equals 4 minus 3. Yeah, or you could move it back. So let's move it back then. Another line we would write, and you get x plus 3 equals 4. So you can move it back and forth, whatever is preferable to do to solve for x. So that's what you can do, and I've put that here. If you move it across the equals in horizontally, all on ground level, then you flip the sign of the object that you moved. In effect, that's what you do for that process. So that's that rule. Now the times and divide rules then, well, how are they to be interpreted? Well, you take this example here, 1/4. We can move that from divide on this side to times on the other side, can't you? Basically, we said, let's quadruple this side and quadruple that side and see if, in effect, we'll do it the long-winded way to start. So 4 lots of this side will equal 4 lots of that side. And then, in effect, by times in by 4, you just get 1 left, don't you, on here? And you get rid of the 4 underneath. And here, you get 4 lots of what, then? Is it 4x plus 3, or is it 4 lots of x plus 3? Well, if you go back to your scales, we quadrupled this side, didn't we? So quadrupling this side is basically not just quadrupling part of it, you're actually quadrupling the whole side. So that's the key thing. It's a very common mistake, and I did want to mention it in the intro. It's the whole side. The whole side is an object, so be careful, because that's one of the most common mistakes that you see. So here you'll have 4x plus, expanding the bracket, you'll have 4x, 4 of those, and 4 3s are 12. That's 4 times the side, and you get 1, and now we can move the 12 across, and we could solve for x in a sense, wouldn't we? But I'm just illustrating here the sorts of things we do. So here's the thing to remember in words. Times on one side can move to divide on the other side, or divide on the other side can move to times on the other side. Yeah, if you see what I mean. So here's another little point just to finish off with then. On this quarter now, all right, if we've got this x plus 3 equals a quarter, and I've got plus 2, and I want to move that quarter up to get it on everything on ground level, can I move that 4 up? Because it's on divide on this side, isn't it? And move it to there. Can I do that? Well, you can't, basically, and it's very easy to put some numbers in to show that you can't with simple numbers, actually. But I'm not going to spend time on that now. But basically, you can't do that because you're not doing it on the whole side. So, but basically, you need to get the thing that's underneath the whole side, and here it's not underneath the 2, is it? So, in order to move that up to the other side and move the 4, so to speak, that 2 we could write the 2 in quarters, couldn't we? So if I wrote the 2 as 8 quarters, say, which is what 2 is, and then I combined the fractions, so now I'd have 8 plus 1 on the top over 4. So let's just write that down. So I'd have 8 plus the 1 over 4. Now the 4 is dividing the whole side, isn't it? And now it's okay, because it's divide on one side can move to times on the other side. So we can move that chappy from underneath to times on the other side. So there it is, and we can move it, and then we can start moving things around, expanding brackets, and getting the answer for x. That just illustrates it. Not that we would want to do that, but these are the processes and the options that we have with solving linear equations. So I just wanted to say a few words about that. I hope you enjoyed this section, get on with it and get some benefit out of it, and I'll catch you in the next section. Cheers!